All right, first of all, here's what we're doing today. If you need calculators, just let me know. I'll get you one when we get going to it. When we get to the homework, you have homework today. I think it's like 6 problems, 5 or 6 problems, like I said yesterday. It's based on circular motion. This is the last day of it. Tomorrow we're moving on to the trig functions, so trigonometry. So that's kind of in the middle of this section. That's like the next major topic we're going to talk about. So today is about angles. We're still in it. So I want to talk about radians and how to use them in circular motion. I have 2 problems only that I like to cover. And I'm going to get right into them today. That way you can get to your homework and you'll know what you're doing today. When we're finished, I'll make sure I'll post that homework for you right away. So just kind of waiting on you guys for when I should hit post. So no. So we'll get to that here in a second. Okay. All right. We ready to go? Okay. Let's jump right in. So let's start first with a wheel that spins multiple times. So let's say you have a car tire, and the radius of our car tire here is, let's say it's like 18 inches. Okay. Let's say this is 18 inches. Okay. What is that? 1.5 feet? No. Yeah. 1.5 feet. And then, so let's say it's 18 inches, and let's say we spin, I don't know, 5-6 times. Let's go 6 times. Let's rotate the tires 6 times. Completely. So, it's starting right here. It rotates full 6 revolutions. I want to know the distance your car actually traveled.
What if you didn't rotate like a full 6 times? What if it was like 4.75?
Okay, that's fine. If no matter what number that is, so let's say it rotated a half a rotation or 4.75, you still take that number times 360. It'll still tell you the angle that you're traveling at every single time. Yeah? Okay, all right. So again, whatever number I provide you for the rotation or fraction, you just multiply by 360. So in my case, I'm taking 6 full rotations by 360. 6 times 360 is 2,160 degrees. So that's a really kind of a large angle. Again, we went multiple full spins, so that should make sense. And then the idea here is that you take your radius of your car tire and you take it times your angle. Now, the angle that we're using has to be in radians. So we have to do that conversion where you have to multiply by pi over 180. So that's how you convert that. Now, the exact answer of this thing is just you multiply the top together. Okay. So the exact answer of this, you take 18 times the 2,160, and so this ends up being 38,880 pi over 180, and this would be in inches. That's the exact answer in terms of pi. I like to have the exact answer in case we have to use this for a later purpose, but for ours today, you can get to your decimal form really easy because it just asks for what is the distance traveled, so it doesn't worry about the fraction. So you take this number times pi divided by 180. So I'm taking that 3,880 times pi divided by 180, and I'm getting 678.58 inches. Quite a bit. It's a lot. Now, in terms of the feet, that you travel, you divide that by 12. You want to figure out the feet. 56 feet for 6 rotations of a tire. It's pretty good. This room is about 24 to 30. I don't know which dimension. I think it's 24 to the back of the room. So about double this room-ish. So pretty good in terms of just 6 rotations of a car tire. And again, that's being modest on what the dimensions are for the tire. Tires can be much more than 18 inches in terms of radius. That was just from the center to the outside. Now that number could be anything. It could have been in inches, could have been in feet, it could have been in miles. It doesn't matter. I know we did examples yesterday with a Ferris wheel, where a Ferris wheel spins so many times. Same exact concept. You just need the radius and you need the angle. Questions on this first one? Okay, the last problem I want to talk about, and I said I only want to go through 2 today. I want to do a globe problem today because that's going to be in your homework. I think you have 2 of these in the homework today out of your 6 problems, I believe, where it asks for the distance that you're traveling on a globe on the Earth. If you went through a certain angle of like latitude or longitude, and it will tell you the numbers. So, again, I'll just kind of quickly talk about this problem. So, you're on the Earth. You're going to travel through some type of number. Let's go with longitude again this time. It doesn't matter if it's longitude or latitude. So longitude is going north to south. We'll kind of exaggerate this. So let's say this is 50 degrees north. And we're going 32 degrees north, whatever the city is, city A and city B. And those are the latitude numbers. And I want to know what is the distance between the 2 cities. And they're directly north and south of each other. So you don't have to worry about that. If it was longitude, they're east and west of each other. And we're just going straight. We're not doing like a weird like angle at it, because then it would require Pythagorean theorem, and I don't want to do that. Not today, anyway. To figure out this, to figure out your angle here, I will provide you this number. The radius of the Earth that we're going to use for every problem today will be 3,960 miles. I think according to Google, it's like 3,955 miles or some weird number.
58.
58, is that what it is? Okay, so Google has some weird number that it kind of comes up with for that. It does actually change. I say it's weird because north and south is different than east and west on the globe in terms of radius, because we're kind of elongated just a hair by like a football. We're off, the north and south number is compressed by about 25 miles compared to the east and west number. So it's because we're on the galactic plane that kind of stretches us a long ways because of the planetary bodies pulling on us, causing like tidal effects. So, so in this particular case, we're going to use the 3,960. I think I use that for every problem today. So your formula: you take your arc length times the radius of your Earth. You take this times your angle. Now the angle that we're using is the difference between 50 and 32. What is that, 18 degrees? And we have to take that times pi divided by 180. Again, where I'm getting this 18 from, it's the difference between these two. If it was east-west, same thing, just subtract them. And again, when you look at a snapshot of this, this is why it's coming up with that. It's the distance to the core. That's where these angles come. So that's why I'm finding this angle. That's the 18 degrees. That's just the angle difference to the core of the Earth. That's how longitude and latitude work. So again, the exact answer on this one, if you take that 3,960 and we take that times 18, this turns out to be 71280 pi divided by 180, and this is in terms of miles. That's the exact answer. That's just taking the 3,960 times 18 times pi over 180. And then if I actually finish this out and actually get the decimal form of this, so take it times pi divided by 180 and actually finish it out, it tells me that the distance between these cities ends up being approximately 1,244.1 miles. Pretty long distance. That's about the distance from, I think, the top of Minnesota down to Texas. So, in terms of like realistic numbers. So, okay, questions.
So for the 18 degrees in the middle, does that come from the 50 degrees and 32?
Yeah, the 50 and the 32. This is subtraction of those.
7?
Yep. Yep. Yeah, so whatever latitude numbers I give you, you subtract those. If I give you longitude, same thing, you just subtract those. Yep. Okay, questions. That was good, though. Any other questions with these types of problems? If you notice, they're meant to be like pretty straightforward and easy. The only difficult ones is when they don't give you like a full rotation. Like Kylie's example earlier, she said like, what if you rotated like 4.75 rotations? Like you didn't go quite a full rotation. You still do the same thing. You multiply by 360 and it gives you your angle. If they give you a fraction, you went 5/8 of a rotation. Fine, multiply by 360. It tells you your angle you went through. The clock problem. We talked about that yesterday. Mm-hmm. If you do a clock problem, you have to figure out the degrees. Every 5 minutes on a clock is 30 degrees. That was or you go like you just set up whatever number you land on over 12. So if I land on the 5, 25 minutes, you put 5 over 12, right? Because it's the marks on the clock. That gives you your fraction of rotation. I think in all of your homework problems, I think there's 6 problems. I think there's one tricky one. There's only one, and it's based on the clock. It's one where you have to actually think about it, because you're going to do more than one rotation. So, all right, questions. Okay, I'm gonna turn you loose right now. I'm gonna stop this video here, so you guys can go work on your own.